Welcome back to another video. Today we're going to look at solving a simultaneous equation that involves logs. One of the first stages here is knowing our log rules. So I'm going to write all the log rules that I'm going to use, or I'm going to need in fact, here. So we know log A plus log B is log AB. Notice that I don't have any particular base, which means base could be anything. Log A minus log B is log A over B, and n log A is the same as log A to the power of n. Hopefully that should be all the rules that we're going to need in this case. So let's go and start with solving the first part. I want to rearrange them. So I've got log y base 2 is equal to, I'm going to change this 1 into log 2 base 2 so it matches this one. Now, because there's a plus in the middle, I'm going to multiply the argument. So I've got 2 lots of 3 minus 2x, also base 2. Notice that because the base is 2 and they're both logs, I can simply say I'm raising it to the power of 2 and conclude that y is equal to 6 minus 4x. So that's the first equation. Let's do the same with our second equation. So log, I'm going to combine the 2 because it's plus again and say log xy base 4 is equal to half. Multiple ways of approaching this, but again, we can go backward on log and bring indices and say xy is 4 to the power of half, which is in fact 2. So I'm going to say xy is 2. And now we're facing a very basic simultaneous equation where y is equal to 6 minus 4x and xy is equal to 2. So what we're going to do here, we're going to change our pen first, and then I'm going to say, right, I know y is 6 minus 4x, so I'm going to substitute that in here and say that's 6 minus 4x, and that's equal to 2. Expand it. So we have 6x minus 4x squared is equal to 2. If I rearrange it and also divide by 2, I'll have 2x squared minus 3x plus 1 is equal to 0. If you have been following us for a while, you would know that I'm going to double that to get 2x minus 1 and 2x minus 2, which in fact implies that x is a half and x is 1. I'm going to go and find the matching or corresponding value for y. So xy is 2. So if x is half, y must be 4. If x is 1, y must be 2. Well, realistically, I'm done here, but I have to check if these values fit in the domain, because I should never have a negative argument. So if x was half, I would get 3 minus 1, which is 2, that's okay. If x was 1, that also works. So both of our values are valid, so we're done here. And this will be the end of this video. If you have any questions, please drop me a message.